Hello and welcome to York Observatory's weekly Teletube broadcast, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Alumni Carswell Observatory located at York University in Toronto, Ontario, Canada. York YouTube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have of our past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @York Observatory and on Facebook at Alumni Carswell Ops. Good evening, everyone. I'm Maheen, and I'll be one of your hosts this evening along with Sergiy, Zena, Marianna, Camila, and Nakul. Happy New Year, everyone. Tonight is our first episode of the year 2023. And to start this year the right way, we've got an episode that will reflect back to the best 10 of all Teletube episodes of the year 2022. Stay tuned to hear about our favorite episodes from the year and what makes them so special. Before we get started with our main show, I would like to mention that the observatory at York campus is in Toronto, and we would like to welcome you all to our show and to acknowledge the traditional land that our telescope is on. The observatory acknowledges its presence on the traditional territory of many Indigenous nations. The area known as Takaranto has been taken care by the Anishinaabe Nation, the Haudenosaunee Confederacy, the Huron-Wendat, and the Métis. It is now home to many Indigenous peoples. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. Our stargazing and astronomical efforts join the long history and current practices of astronomy for this land. The observatory looks forward to continuing to learn and revitalizing our knowledge in this area. I'll now pass it on to Zena to give us some updates on what's up in the sky this week. Take it away, Zena.
Thank you, Maheen. I would just like to mention that this part is written by Marianna, and I will be delivering her parts today. So welcome, everyone. Before we get started with our main show, we want to give you a little update on what you can see this coming week. The moon is in the waning gibbous phase with an illumination fraction of around 83% as seen from Earth. This is the first phase after the full moon occurs and will last around 7 days. As each day passes, the illumination fraction will grow smaller and approach an illumination of 50% by this Saturday, January 14th, and this will be the last quarter moon. The sunset tonight was at 5:03 p.m. Eastern Standard Time, and there are still many objects in the sky to see. Starting off with Jupiter, which has fairly good visibility, and Saturn. Both can be viewed in the evening after sunset. Look for the brightest object in the night sky that is not twinkling and not the moon. That would be Jupiter. It'll be located west-southwest in the sky, and Saturn follows Jupiter by being the next brightest object in the night sky. And although they can be seen without fancy equipment, binoculars, or a small telescope, these are still recommended because it would make the rings of Saturn and the bands of Jupiter more pronounced. We are lucky because this week Mars reaches a stationary point in the sky and will look like a red star. Mars will be visible to the naked eye, however, binoculars or a small telescope are always recommended. The comet C2022 E3 ZTF is currently passing through the inner solar system and will make its closest approach to the Sun tomorrow, January 12th. This distance between the Sun and the comet at this time will be 1.11 AU, or atomic units. The comet can be seen with its green color in the northern hemisphere with binoculars or a small telescope. To catch a view of it, look between the constellations of Corona Borealis and Bootes. However, with this being said, the comet will be closest to our planet Earth, or perigee, and be at its brightest on February 1st and 2nd. These objects will be visible all week long, so make sure to get outside and look up at the stars. Now I'd like to give it away to my colleague Maheen.
Thank you, Zena. So, Starting off with one of our amazing events and one of my personal favorites, Herschel's 200th anniversary. This event was held in person. However, this Teletube episode was a replay of the event for people who couldn't make it. The reason that this is one of my favorite episodes is because of the violin concert at the end of the amazing lecture by Dr. Prandis Tajbaksh. It was interesting to be able to relate a piece of music to William Herschel, who was an astronomer. All of the violinists did an amazing job, and I'd like to share a small clip of them playing. I will now pass it over to Sergiy to share some of his personal favorites.
Thank you, Maheen. Personally, I found the episode with the observatory staff and their guests enjoy astronomy-related games to be the most enjoyable. The most interesting of which took place on September 14th, 2022, which was the game of Jeopardy, with interesting, non-obvious, and thought-provoking questions being asked, such as, in what constellation is the center of the Milky Way? And yes, it is Sagittarius. The following is a short clip from that Teletube episode.
I will stars 400.
Oh, okay. So you're gonna take out the stars. Okay, what determines the death of a star? A, temperature, B, luminosity, C, radius, D, mass. Nakul, go ahead.
I would say the mass of the star.
D? Okay. Let's
Yes.
see if your answer is correct. Okay. Oh, your answer is correct. Congratulations. You get 400 points. Wow.
The other game that everyone enjoyed was Astronomicers, where you had to describe an astronomical topic without saying certain banned words. An example of this would be trying to describe Mars without saying the words red, planet, orbit, or rover. The following is a clip from the Astronomicers Teletube that took place on January 12th, 2022.
Right. Hopefully this one's not that hard, since this has been very, very scary with all the fancy terms.
Okay, I like this one. So the southern celestial sphere does not have
Aurora Borealis?
does not have a ball of plasma like this one.
Pole star, like the Polaris.
Yes.
Yes.
Hooray! Polestar. Is it Polaris or Polestar that won?
It was Polaris.
Aha! Very good, very good. Julie, you're making somewhat of a clean sweep of points here. This is very, very good. All right, so Rosela, that was your clue. Can you post it in and we'll copy it over for just in case anyone is curious. What exactly was the description? I guess star was on the forbidden words.
Yes, it was. The ball of plasma is very clever.
My other favorite Teletube from last year was the episode that aired on the 13th of July 2022, which had our esteemed guest speaker, Jesse Rogerson, discuss the first images from JWST. Everyone was waiting very patiently for the images to be released since December 25th, 2021, when it was launched. Please enjoy the clip from the Teletube episode.
They released this one early. It was on Monday night, as opposed to with the rest of them on Tuesday. But on Monday night, they released this one, and what you're looking at here is Webb's first deep field. And this is reminiscent of the Hubble Space Telescope because one of the most iconic images of astronomy ever is the Hubble Deep Field, which is just taking the telescope, pointing it at a location on the sky and collecting data for a very long time. So like in photographer speak or in astronomy speak, exposing for hours and hours and hours and hours. And the image you see here is the culmination of 12.5 hours of collecting data on a tiny little pinprick of the sky. So it's, imagine the amount of space that this image takes up. The amount of space that you see here is take a grain of sand in your hand and hold it at arm's length. That the little angle, the little tiny area that covers the sky by that little dust grain, the sand grain, is how much space is taken up by this image. So it's a small portion of the sky, but every single point of light that you see here, every single point of light, except for the ones that are spiky. So meaning like this one here, and that one, and that one, and that one. These spiky ones, those aren't galaxies, but everything else is a galaxy, like our galaxy.
Now I will hand it off to Zena, who is presenting Marianna's favorite Teletubes from 2022.
Thank you, Sergey. I'll have to agree those Teletubes were quite interesting and very worthy of being in the top 10. Now for my favorite Teletube, I would have to choose the Teletube on November 30th, 2022, which was about the search for alien life in the universe. I have always been interested in alien life when I was younger, and still to this day, no one can convince me that there are not other life forms out there. In the Teletube, there was a guest speaker, and his name was Dr. Adam Frank, and he gave a fascinating presentation on this topic. He talked about some history of the search for alien life, famous scientists, research and understanding the possibility of life, Fermi paradox, and much more. One thing that stuck out to me, however, during this Teletube was the section on the Drake equation, which not only supports the idea of extraterrestrial life, but actually gives a formula to calculate the number of interstellar civilizations in the Milky Way galaxy that we could communicate with. This equation was formulated by Drake, Morrison, Oliver, Lilly, and others. It is just fascinating to me that this idea of alien life could be understood via mathematics as well. This equation is explained in further detail in the next video clip.
In this equation, let me just go through this. R here is the number of stars in the universe, or in the galaxy, excuse me. Actually, it's the number of stars forming per year, which is just another way of saying the same thing. F sub p is the fraction of those stars that have planets. N sub e is the number of those planets that are in the right place to form life, meaning that you could get liquid water on their surface. F sub L is the fraction of those planets that have liquid water on their surface that actually go on to form life. F sub I is the fraction of that life that goes on to form intelligence. F sub T is the fraction of those intelligent species that actually produce technological civilizations. And L is how long those civilizations last. And so if you knew all of these numbers and multiplied them together, you would get the total number of civilizations in the galaxy. And of course, if N is very large, then there's a lot of civilizations to find. And if N is 0, there's nobody else out there. And so this...
The next Teletube I'd like to discuss is the Teletube that was broadcasted on December 14th, 2022. The discussion here was about the 5 Mars years of the Curiosity rover cloud observation that was presented by the guest speaker Connor Hayes. Since there is a lot of talk about exploring Mars and sending humans to Mars, I thought this amazing discussion was fit to be one of the top 10 Teletubes of the year. In this discussion, Connor goes on to talk about cloud formation, cloud characteristics on Mars, how the Curiosity rover was able to study these clouds, and he also showed amazing images that were taken from Curiosity rover itself. From this, I learned a lot about clouds on Mars, and I am interested to see how these clouds will affect humans when we get to Mars. I do believe that the data collected within those 5 years will pose to be useful for the future Mars missions. The video I chose has images of gravity wave clouds and dust devils that were taken by the Curiosity rover. Connor goes on to explain these phenomena and show breathtaking images in movies.
near cloud features. So in these movies, you can see that the spacing and the size of the gravity waves can vary. They can either be very closely spaced together or very far spread apart, although admittedly this could be caused by altitude differences, with higher altitude gravity waves looking like they are closer together. And they can either cover the entire sky, as they seem to up here in the top left, or they can just cover a very small portion of the sky, as you see in these two movies here in the bottom right. We also do occasionally see dust devils and other dust lifting events in these super horizon movies, thanks to the fact that they look out over nearby and distant terrain. These sort of events aren't particularly useful for our cloud studies, but they are fun to look at regardless. So in these 4 movies here, you can see these 3 dust devils up here. And then down in the bottom right is a particularly heavy dust lifting event, which I've highlighted because there's actually so much dust being pulled up into the atmosphere here that you can see it in the raw frames of before mean from subtraction. If you look just over this little hill here, see all that dust being blown into.
I can keep talking about these amazing teletubes, but I will pass it on to Cam so she can tell us her favorite teletubes from 2022.
Thank you, Zena. I can say that those 2 episodes for sure deserve to be in our top 10 best of 2022. Personally, I think our solar system is a very important topic to talk about. That is why I picked this next episode. Going back to March 23rd, the solar system and beyond Teletube introduced us to all the planets orbiting our sun, as well as the galaxies that our solar system orbits. There was one particular part that I wanted to share with all of you, since it's my favorite planet after Earth.
One planet which has a few planet-sized moons is Jupiter. The 4 so-called Galilean moons are Io, Callisto, Europa, and Ganymede. Io and Europa are similar in size to our own moon, but way more active. While Callisto is just smaller than the planet Mercury. And Ganymede, get this, is a whole 26% larger than Mercury by volume. Jupiter also has 80 known moons, but more and more are discovered each year as Jupiter competes with Saturn for who has the most moons. Jupiter is also 778 million kilometers away from the sun on average, giving it a nearly 12-year journey around the sun. But despite having such a long year on Jupiter, a day on Jupiter is only 10 hours. Lucky astronomers may be able to observe an entire Jovian day in a single night of observing. That means you have a better chance of observing Jupiter's Great Red Spot. As seen here, it's a massive red-colored storm, which has existed for at least 300 years on Jupiter, and is one of the countless storms covering its surface.
I just wanted to emphasize the importance of this planet. Jupiter actually protects Earth by deflecting comets and asteroids that will otherwise strike us. And without it, we wouldn't have a stable environment for life to evolve. It is hard to imagine that our existence depends on so many factors, and the fact that our solar system contains all of them is just amazing. The second episode I picked was one of the most interesting of 2022 in my opinion. Back in June 29, the JWST Teletube introduced us to the space telescope that everyone is talking about these days. At this time, we were all eagerly waiting for the telescope to reveal images in a way we'd never seen before. And this part in particular showed the galaxy images we were expecting to see in the near future.
Hello, everyone, and welcome to York Observatory's weekly Teletube broadcast, the online astronomy and astrophysics program.
Galaxies interact and evolve with their black holes. There will also be lots of work done to find. Webb's first science theme for the ERS programs is studying galaxies. These programs tend to focus mainly on galaxy evolution and interactions, which includes galaxies' central massive black holes and the way that galaxies interact and evolve with their black holes. There will also be lots of work done to find and characterize faint, distant galaxies, including some of the first galaxies to form in our universe. The images on the screen are some of the galaxies that will be observed by Webb as part of the ERS programs, and the images are all taken by the Hubble Space Telescope. Some of these targets include a massive galaxy cluster called Abell 2744 and 4 galaxies which are disturbed from interactions with other nearby galaxies. In addition to these, Webb will also observe bright infrared galaxies and luminous quasars.
Moving on to tonight's Teletube, we can finally see the galaxy that we wanted to see back in June. And that is what we are all seeing in this slide. I have to say that even though we've seen many of them at this point, I think we can all agree that every time a new image is published, it amazes us the same way that the first one did. Last but not least, my third favorite episode takes us back to August 17th. This episode talks about the constellation of Perseus, its mythological history, as well as its annual Persei meteor shower. I personally love this constellation because it contains beautiful objects like Messier 34, the California Nebula, and the Little Double Bell Nebula. Here we can see the images taken by NASA. The part that I chose to share with all of you is particularly interesting to me because it focuses on the importance of Perseus to ancient civilizations.
Yeah. Since ancient times, astronomers like Ptolemy named Perseus as one of the main constellations that is still an important one among the 88 modern constellations according to the IAU, or the International Astronomical Union. A little fun fact about this constellation is that in ancient times, constellations like Perseus were made use of to create and track the calendar so they knew when to plant crops and harvest them, or simply for going by their days and make different arrangements with respect to the seasons.
It's amazing to see how essential constellations like Perseus were and still are for us, and how they share a special part of human history as useful resources to guide civilizations to successful achievements. Well, that is all for me, and I am now giving it away to my colleague Nakul.
Thank you, Camila. I'm really to say those episodes are very good one. And so I'm starting off with the last best episode of 2022, which is the Teletube of July 27, 2022, which is about the evolution of telescope. We had a guest speaker, Zena, who is a student from the University of Manitoba. He talked about the types and functions of the telescope, wavelengths, and a brief introduction to the space telescope missions to date. And of course, we had a chance to ask him some interesting questions related to telescopes and its evolution. Let's have a sneak peek about the difference between the reflective and refractive telescope from the episode.
So we have two main types of telescopes. We have refracting telescopes and reflecting telescopes. Refracting telescopes are relatively simple. They have two lenses. Let's get this out of the way. So they have two lenses, and essentially what they are is a tube with one lens on one end and an eyepiece or a second lens on the other lens. And the light that approaches one of the lenses is converged within the tube and then directed towards our eyes in the eyepiece. And what this does is it creates a magnified image about all of the light rays that we are exposing our telescope to. Reflecting telescopes are a little bit more complex in that they use mirrors to reflect light into our eyes. Instead of using lenses to bend light towards us, we use mirrors to collect light, reflect it into a secondary mirror, and then that secondary mirror sends the light that we have condensed with the primary mirror into our eye. And this effectively does the same thing. You know, we're creating a magnified image, which is the absolute point of having a telescope.
Well, everyone, you have been listening to the Alan I. Carswell Observatory's weekly Teletube broadcast, the Astronomy and Astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Maheen, Marianna, Zena, Cam, Nakul, and myself, Sergiy. Make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now. We'll be around for the next 20 minutes to answer your questions. All of our programs are free, but if you'd like to make a donation, see our website at yorku.ca/science/observatory. You can always connect with us on Twitter with the handle @YorkObservatory and check out our website for show notes, content, updates, and contact info at yorku.ca/science/observatory. Thank you for tuning in, clear skies, and have a good night.